Alrighty, so this is going to be a short video just looking at some practice questions with Hooke's law. So we're essentially going to be using the equation F equals K delta L, but we've got a few variations in the situation. So let's start off with, we want to calculate the force constant or the spring constant when it's stretched 3 millimeters by a force of 12 newtons. So I typically work in standard units, which would be meters for distance. So the first thing I'm going to do is convert the 3 millimeters into meters by dividing by 1,000, which is the same thing as timesing by 10 to the minus 3. Once we've done that, we can use F equals K delta L, rearranged to make K the subject, substitute the numbers in, and we get a force constant of 4,000 newtons per meter. Now, we could have just done 12 divided by 3 and got 4 newtons per millimeter, which is fine, but as I said, I typically work in standard units, so I'm always going to make the conversion. What is the force constant of a spring which is stretched 8 centimeters by a mass of 4 kilograms? So first of all, I'm going to convert the distance into meters again by dividing by 100. And we also need to calculate the weight force of the 4 kilogram mass. So we're going to multiply it by 10. And then once we've done that, we can substitute that in and get the force constant of 500 newtons per meter, or we could have just had that as 5 newtons per centimeter. That would be fine too. So what is the force constant of a spring which is stretched from 16 centimeters to 21 centimeters by a mass of 200 grams? So we've got quite a few conversions to make here. We've got 5 centimeters into meters and grams into kilograms to get into our standard units. Then we can calculate the weight force of 2 newtons, and then we can substitute that in to give us 40 newtons per meter, or 0.4 newtons per centimeter. Okay. So moving on to some more questions. So a spring of force constant 14 newtons per centimeter, and you do need to pay attention to units here, is stretched by 30 millimeters. What is the applied force? So what I'm going to do is I'm actually going to convert the millimeters into centimeters, so that when we multiply it by 14 newtons per centimeter, that just gives us newtons. So I can just put this into the equation, do 14 times by the 3 centimeters, giving us 42 newtons. So we don't always have to convert into meters and newtons per meters. We can find some slight shortcuts. A spring of force constant 0.2 newtons per millimeter is stretched by a force of 13 newtons. What is the extension? Well, again, we're using F equals K delta L. And this time we want to calculate the delta L. So if we do force divided by newtons per millimeter, that's going to give us the extension in millimeters, which we could then convert to centimeters, meters if we wanted to. And then final question here, a spring in the diagram stretches from 10 centimeters to 22 centimeters when a force of 4 newtons is applied. If it obeys Hooke's law, the total length in centimeters when a force of 12 newtons applied is... So first of all, we've got the change in length of 12 centimeters. So if we do the force of 4 divided by 12, that gives us a spring constant in newtons per centimeter. So then we've got the force is now 12. So we can put in force divided by the spring constant gives us our unit of delta L, and then we need to add on the original length to get what the actual length is, which is what has been done here, and that completes this question.